One. Okay, so the next program we're about to create is, or the next program in chapter 5 is isPrime method. So a prime method is a number that is evenly divisible only by itself and 1. For example, the number 5 is prime because it can be evenly divided only by 1 and 5. The number 6, however, is not prime because it can be divided evenly by 1, 2, and 3, and 6. 1, 2, 3, and 6. Write a method named isPrime, which takes an integer as an argument and returns true if the argument is a prime number, or false otherwise. Demonstrate the method in a complete program. Okay, so basically for this one we are going to, over here it says tip. Recall that the modulus operator divides one number by another and returns the remainder of the division. In an expression, such as num1 modulus num2, the modulus operator will return 0 if num1 is evenly divisible by num2. So this program is going to be, in this program we are going to define the method. We're going to create a method called isPrime, and that method is going to accept a number. Okay, it's going to accept a number, and it's going to return true if that number is prime, as a prime number, or false if that number is not prime. It's not a prime number. Now, over here it says that a prime number is a number that is evenly divisible only by itself and 1. So evenly divisible meaning that if you take, for example, if you divide 5 by 1, you get 5 remainder 0. You get no remainder. You don't get 5 point something. You don't get 5.2. You don't get any remainder after that. If you divide 5 by 5, you get 1 remainder 0. But any other number, like 5 divided by 2, gives you a remainder of, let's say, this one gives you a remainder of 0.5. 5 divided by 3 gives you a remainder of 0.666. So basically, if that number is prime, in this case 5 is prime because it's evenly divisible by itself, which is 5, which gives you 1 remainder 0, and 1. 5 divided by 1 gives you 5 remainder 0. Any other number that gives you or that can divide by let's say more than 2 numbers. So that can evenly divide more than 2 numbers. It's not a prime number. So, for example, 6 can evenly divide, or let's say 1, 2, 3, and 6 can evenly divide 6. So in that case, 6 is not a prime number. For a prime number, or for a number to be a prime number, okay, it has to it has to be only evenly divisible by itself and 1. So as we create the program, I'll explain more so we get an understanding of it. So I'm going to explain how I'm going to solve this, how we're going to solve this. So first of all, let's just go ahead and create the class. So public class, I'll call this isPrime method. Let's see, isPrime, capital, isPrime method. And then I'll create the main method. Okay, so let's see. Okay, so now we know we are going to define the method. We know some details about the method, so let's go ahead and do that. Now, in previous programs in chapter 5, I've always mentioned that others define their methods right under main, and even the author of the book, Tony Gaddis, he defines his methods right under main. It's still going to work as long as you define it. When you define it, it's available to be called. Okay, you can call it in main whilst it's defined below main, and it's still going to work as long as you even if you define it below main, it's available. In this class, you can call it. So you can do that if you want, but I'm going to go ahead and define mine above main, and it's still going to work too. Because I do that just because I'm used to doing that for the most part. But sometimes I also define it below. So you can choose to define it below main or above main, and it should still work. So I'm going to define mine above main. All right, so I'm going to create a public. I'm going to create a public static method. It's going to be a public method because this it's going to be a public method because this method is going to be available to code outside this class, and it's going to be a static method because this method belongs to this class. So now I need to specify the return value, right? So let's see. So we know that it's going to return true if the argument is a prime number, or false otherwise. So we know it's returning either true or false. We know that's a Boolean. So now we have to specify the return type as a Boolean, either true or false. So public static bool for a Boolean. Let's see, Boolean. You can I think Boolean or bool. I've never tried. Okay, anyway, it's going to be a Boolean. Public static Boolean. And now we have to specify the name of the method. Now we know the name of the method is isPrime, but over here it says, specifically it says write a method named isPrime. So I'm going to name it isPrime. And just 1 second here. Okay. So now I know the method is going to accept some arguments, so I'm going to define some parameters. Over here it says that write a method named isPrime which takes an integer as an argument and returns true if the argument is so we know it's taking an integer argument, so we need to define an integer parameter, which is basically going to hold whatever the user passes as an argument into this method when it's called. So I'm going to define an integer argument, so int. I'm going to call this user number. It's just a variable that's going to hold the number that's passed into this method anytime the isPrime method is called. So yes, I'm doing that. I'm passing in user number. Okay, so in this method, that's where we want to really do the processing and see, basically process this number and see if it's a prime number or not. So like I said, I normally say that for a number to be prime, okay, if you divide all the numbers in the world, let's say if you divide that number by all the numbers, let's say if you divide the number by from let's say from 1, okay, or let's basically all numbers, okay, basically all numbers. If you divide that number by all numbers, it should only give you 2 even divisions. And I say even divisions is basically a division where there's a remainder of 0. So if you divide that number by any number, it should basically when you divide that number by all the numbers in the world, I'm not talking about complex numbers and just regular integers. If you divide number by all integers, you should get only 2 even divisions. So 5 is a prime number because if I divide, let's say I start from 1 to 5, 1 divided by, sorry, no, 5 divided, I'm dealing with 5 now. So 5 divided by 1 gives me 5, with a remainder of 0. So now I have 1 even division because this gave me a remainder of 0. 5 divided by 2 gave me a remainder of 0.5. So that's not an even division, so I don't count that as an even division. So I still have an even division of 1. 5 divided by 3 gives me a remainder of 0.66. So that's not an even division because it didn't give me a remainder of 0. It gave me a remainder of 0.66. 5 divided by 4 gave me a remainder of 0.25. It didn't give me an even division. So I still have an even division of 1. 5 divided by 5 gives me 1 with a remainder of 0. So now I have 2 even divisions. So if I'm starting from 1 all the way to 5 and dividing that number by, let's say, 1 all the way to 5, by the end of all those divisions, I should end up, if that number is truly prime, it's truly a prime number, I should end up with only 2 even divisions. Now the question over here says, a prime number is a number that is evenly divisible only by itself and 1. Only by itself and 1. Okay, so we know that we are going to have 2 even divisions if we divide all the numbers in the world, if we divide 5, or basically that number, by all the numbers in the world. So first of all, I'm going to define a variable in main, and I'm going to call, this is going to be in the isPrime method. All right, so I'm going to define a variable in the isPrime method, which is going to keep track of all the even divisions. So I'm going to define, it's going to be an integer variable because it's just going to be a count of all even divisions. All right, so I'm defining it as an integer, and I'm calling it even divisions, and I'm setting it to 0 initially. I'm setting it to 0 because before we count the even divisions, we have 0. So we're going to start counting from, basically it's going to go, you count, when we add 1 to it, it's going to be 1. Even division is going to be 1, add another 1 to it, basically counting. Initially it's 0. So once I've set my even divisions to 0, now I want to check to see, basically I'm going to create a loop starting from 1 all the way to that number. I'm starting from 1 all the way to that number and dividing that number by 1, by 2, by 3, all the way to that number. If that number is 5, I'm dividing 5 by 1, 5 by 2, 5 by 3, 5 by 4, and 5 by 5. If it's 6, I'm dividing 6 by 1, 6 by 2, all the way to 6 by 6. And throughout all those divisions, if I get a remainder of 0, okay, I'm going to keep track of how many even divisions I have. If by the end of all those divisions I have a remainder of, I have even divisions of more than 2, then I know that number is not prime. If at the end of all those divisions I have, even divisions of exactly 2, then I know that it has to be exactly 2, because for a prime number there has to be exactly 2 even divisions. The number divided by the number itself, and the number divided by 1. So if I have, at the end of all those divisions, I have exactly 2 even divisions, then I know I have a prime number, so I'm going to return true. Now, if the even divisions is at any point whilst I'm doing the divisions and keeping track of the even divisions, if even divisions is greater than or equal, it's greater than 2, meaning if it's 3 or above, if it's greater than 2, then return false. And then that means that number is not a prime number. So I'm going to create an if statement here. Well, first of all, a for loop to basically keep on dividing. So I'm going to start a for loop over here. Sorry. And I'm starting from 1, right? So I'm starting from 1. And I'm going to call it, let's say, current division. I'm just going to call it current division. I don't have to call it current division, but you can call it just division. But I'm calling it's going to be an integer current division. Okay, it's going to be an integer current division. I'm starting from 1. So I'm initializing current division to 1. And as long as current division is less than or equal to the number itself. Okay, so this is where we haven't. Okay, we have the number here. I thought we were prompting the user for that. We have a method here. The user is going to pass in the number here. All right, so as long as the current division is less than or equal to, let's see. No, actually, this is not. Let's call it. This is actually not current division. The name doesn't really describe it. It's actually not current division. Let's name this variable starting point, or basically starting number. Okay, starting. Let's see. Should I say current start? I'll stick with current division. It describes it. I thought it didn't describe current division, but it does. So basically, it's starting from 1, going all the way to the number itself. It's current division because it's going to divide the number by 1, divide the number by 2. So this is keeping track exactly, starting from 1. So yeah, current division is fine. So let's stick with current division. So we are starting current division from 1, and as long as current division is less than or equal to the number, which is user number over here, the number itself. Okay, so we're starting from 1 all the way to the number itself. If the user typed 3, we're starting from 1 all the way to 3. And we're dividing the number by 1 initially, the number by 2, and the number by 3. So because if the user typed in 3. Assuming the user typed in 3. So we're starting from 1, current division is starting from 1. As long as current division is less than or equal to the user number, we are doing what's in this for loop. And before we come back up and check to see if current division is less than or equal to user number, we want to add 1 to current division. So basically, we are starting from 1 all the way to the number itself. Current division is starting from 1 all the way to the number itself. Plus. We're adding 1 to current division. So current division starts from 1. And as long as the current division is less than or equal to the user number, we are doing what's in this while loop. This for loop, we're doing what's in this for loop, and before we come back up and check to see if current division is less than or equal to the user number, we are adding 1 to current division. So basically we're starting from 1 all the way to the number itself. So initially current division is going to be 1. It's going to do check to see if 1 is less than or equal to the number itself. And if it's less than or equal to the number itself, it's going to do what's in the for loop. Before it comes back up and check to see if current division is less than or equal to the number itself, it's going to add 1 to current division. So current division is going to be 2. And it's going to check to see if the current division is less than or equal to the number itself. It's going to do what's in the for loop. So basically it's iterating and doing what's in this for loop, starting from 1 all the way to the number itself. So current division is going to keep track of basically the number. So it's keeping track from 1 all the way to the number itself. So 1 to all the way to the number itself. So we can use that number to basically do the divisions. Okay, so if the user typed in 6, we know current division is starting from 1 all the way to 6. Each time it's going to increment from 1, to 2, to 3, all the way to the number itself, assuming the user types in anything greater than 3. Okay, so what we want to do is we want to go ahead and check to see if the division, okay, the number divided by the current, the current number for division is gives us a remainder of 0, and that's where he hinted us and said we should use a modulo sign. So I'm going to say if, I'm going to create an if statement. Let me just create the block here. I'm going to say if the user number, the number that the user passed in as an argument here, okay, if the user number modulus, okay, now we are using the modulo sign, right? We're using the modulus symbol. If the user number modulus or modulus, if the user number modulus, let's see, current division gives us a remainder of 0. If the user number divided, so basically, if the user number divided by current division gives us a remainder of 0, modulus basically divides these two numbers, but it doesn't give us the answer of the division. It gives us the remainder after the division. So 2 divided by 2, instead of this giving us, let's say, 1, it's going to give us 0, because after we divided 2 by 2, we ended up getting 1 all right, but we got a remainder of 0. Modulus gives us the remainder and not the answer. So it's going to keep dividing the number by the current division. So we're just going to start from 1 all the way to the number itself. And if it gives us a remainder of 0, then we know that we have an even division here. So let's go ahead and add 1 to the even divisions. So even divisions is going to be equal to what's already stored in even divisions plus 1. Okay. So even divisions initial is going to be 0. If really the division ended up with a remainder of 0, then we have one even division. So initially, even division is going to be 0 plus 1. And the whole 0 plus 1 is going to be 1. 1 is going to be stored in even divisions. Even divisions here, S. And then it's going to loop again over here. If it loops again, or iterates again, and the division, the current division basically ended up with a remainder of 0, it's going to add 1 to even divisions. But guess what? Even division is already 1. So it's going to be 1 plus 1, and 1 plus 1, 2 is going to be stored in even divisions, because 1 plus 1 is 2. 2 is going to be stored in even divisions. And it's going to keep going and keeping track of even divisions. Now, anytime it adds 1, okay, so anytime it adds 1 to even divisions, we don't want to wait till it's done, keeping track of all the even divisions. So if the person types 1,000, we don't want to wait till it basically does all the even divisions to check to see if to check the even divisions. So at any time, at any point in time, after we've added 1 to even divisions, let's check to see what's in even divisions to see if it's greater than 2. Because if it's greater than 2, then that number is not prime. For a prime number to be a prime number, okay, for a number to be a prime number, it has to have exactly 2 even divisions: the number divided by the number itself and the number divided by 1. Anytime it adds 1, it's possible to have more than, let's even 5 even divisions. Like for example, 6. if the person typed in 6 and we started from 1 all the way to 6, 6 divided by 1 gives us 6 divided by 1 gives us 6. We can do it here. 6 divided by 1 gives us 6. Remember 0, right? Gives us 6, remainder 0. So now even divisions goes up to 1. And then 6 divided by 2 gives us 3, right? Remainder 0. So now even divisions gets to 2. 6 divided by 3 gives us 2, right? Remainder 0. So now even divisions goes to 3. Now 6 divided by 4 doesn't give us, it doesn't give us an even remainder. It doesn't give us a 0 remainder. It gives us 1, whatever the answer was here. 6 divided by 5 doesn't give us an even. It doesn't give us a 0 remainder. So even division still holds at 3. Now 6 divided by 6 itself, the number itself, gives us 1 remainder 0. So now even divisions goes up to 4. So that means we already know that if we finish computing all of this and we now check to see what's stored in even divisions, to check to see if it's either 2 or greater than 2, it's going to be a problem if the user types in, let's say, 5,000. We would have to wait for this if statement to basically keep track of all the even divisions before we check. So that will be after this if statement. But we don't have to do that. We can check as soon as we add 1 to it. As soon as we add 1 to even divisions, we can check to see what's already stored in even divisions. If it's greater than 2, okay, we don't have to even continue. If it's greater than 2, we know that number is not a prime number. So over here, when we were checking 6, when we did 6 divided by 1 and it gave us a remainder of 0, we kept track of even divisions. 6 divided by 2 gave us 3, remainder 0, so even divisions became 2. 6 divided by 3 gave us 2, remainder 0, so even divisions became 3. At that moment, we didn't have to continue. At that moment, we could have checked to see if even divisions is greater than 2. And if it was greater than 2, the program will just end and return false. So we don't have to wait till we're done with keeping track of even divisions before we type in an if statement here and check. So anytime we add 1 to even divisions, let's go ahead and check to see if the even divisions is greater than 2. Because if it's greater than 2, then that number is not prime. So we should return false. So if even division, sorry, let me just create the structure. Sometimes I feel like I'm typing in Python, I'm coding in Python. All right, so if even divisions, at any point in time is greater than 2, then we know that number is not prime. So in that case, then return false. We know that with this method we are returning a boolean here, so we're returning false. If at any time we check to see if even divisions with S is greater than 2, then we know that we are returning false. We know that number is not prime. So now we are still here, and we are still in the for loop here. So basically, we know for sure that if that number is not prime, it's going to return false, because even divisions at some point in time is going to be greater than 2, and this if statement is going to catch the number of even divisions and return false at any point in time. So now if at any point in time the number doesn't return false and it's done with this for loop here. It's done with this for loop. Okay, let me just put a space here. So if at any point in time it's done with this for loop and that number didn't return false, then that means that number is prime. Because if you've been able to go through this loop and your even divisions, basically wasn't greater than 2, then that means that it's either exactly 2 or less than 2, right? So let's return true in that case, because if it didn't return false at this point, now when it returns false, it gets out. So it gets out of this method. This method ends. So it wouldn't get to any statement here. Okay, but if it didn't get to this return statement, then it's going to get out of the loop. When the loop is done, it's going to exit the loop and then continue any statements below here. So if the number the even divisions of that number didn't return false, then we know that then that number is a prime number. So let's return true here. If that number is not prime, it's going to definitely return false, and exit the loop. Exit the method itself. So that means this statement is not even going to run. If it gets to the statement and returns false, it's not going to get to the statements. It's going to just exit out of the method. But if it didn't return false at any point in time, if it there wasn't more than 2 even divisions, then the even divisions was either exactly 2 or less than 2. So in that case, we know that exactly 2 is a prime number, so we're returning true. Now the only number that will probably be less than 2 even divisions will be 1. Okay, now we'll deal with that later. But any one or probably -1, but we'll deal with those later. But apart from that, any other number that basically any other number that didn't get exactly 2 even divisions basically is not a prime number. Okay, basically it's not a prime number, and if it's not a prime number, okay, then it's going to return false. So any other number that didn't get exactly 2 even divisions is not a prime number. So if it's not a prime number, it's going to return false. And if it's a prime number, then it's not going to be it's not going to be more than 2 even divisions here. So it's not going to return false. It's going to get to the statement and return true, right? So now we know it's going to work. Now we know it's either returning false or returning true. Now we'll check on one later on. But in the main method, I'm going to call this. Oops, sorry. I thought the name of the method was current division. I'm going to call this method called isPrime, named isPrime. Let me just tighten this up a little bit. Now you see it. So I'm going to call this method isPrime. So isPrime, and I'm going to pass in the number 2. But I want to also print it out because we're only returning it. We're not printing it out. So system .out.println print out what is being returned from this method call. I call this method pass in 2. It's going to return either true or false. Print out whether it returns true or false. Whatever it returns, whether it's true or false, print it out. That's what the statement is doing. So let's check to see. Now, for 2, it should return true, right? Because 2 is a prime. Okay, 2 is a prime. Yeah, I think so. Yeah. So let's go ahead and compile this. We'll deal with 1 and -1. Yeah, those later. But let's. Where are we? Okay, so we're in chapter 5. So I'm going to create a folder for this one. I'll call it isPrime. isPrime method. And save this in here. Okay, so we have a couple of errors. Let's see. Cannot find symbol false. Okay. Let me try a small letter false. And let me try a small letter true. Okay, so now it's fine. I think it takes I think Python takes well, maybe they take both. I think I was used to using capital letters in Python, I guess. But Java takes false or true small letters. Okay. So I'm going to compile this, and actually I did compile it. Let me run it and see what it prints. So it prints true. It prints true. It's telling us that 2 is a prime number. So actually we can go ahead and actually use the number itself also. We can only at this point we can only return 1 value. When we get to arrays, we can return multiple values. But for now, I wanted us to use the number itself, or maybe we can actually allow the user to enter to provide this number and then use that number and say 2 is not a prime number. Okay. All right. So let's try another number. Let's try 3 and compile. Oops. Run it actually. I don't know. Yeah, actually compile. So 3 says true also. And let's try 4. 4 should give us false because actually no. 4 should give us false because 4 divided by 1 is an even division. 4 divided by 2 is an even division. 4 divided by 4 is an even division. So when I run that, compile this, and then run. So it says false. I have a list over here. Let me try 5. 5 should give us true. And it says true. How about 9? 9 should give us false, although it kind of looks like a prime number, but it's false because 9 divided by 1 is an even division. 9 divided by 3 is an even division. 9 divided by 9 is an even division. That alone there is more than 2 even divisions. So in this case, it's going to return false and exit out of the method. So run, compile this first and run it. And it says false. So far so good. So far it's running. I opened the Wikipedia page before this program, giving us a list of all the numbers, basically over here, all the numbers here, all the first 1,000 prime numbers. So we can check some of these. We've already checked some of these. 7 over here. So let's try 7. We already did that, right? Compile and run. 7 says true. So 7 is a prime number here. Let's try 8. 8 should give us false because 8 is not a prime number. So 8 is false. Let's try 23 and then we'll try 24 because 24 is not in this list. Let's try 23 first. So 23. It's true. So that's correct. Let's try 24. It's not in that list, so it should give us false then. And 24 gives us false. Let's go all the way down and try the big numbers, numbers that I don't know. I don't even know how to, So let's try 7757. 7757 should give us true. So 7757. 7757. Compile this and then run. And it gives us true, so that's correct. Let's try 7759. And that should also give us true. See, we get true over here. But let's try something like 7760. It's not on this list. 7760 is not on this list. Actually, even 7761, a number that may seem like a prime number, 7761. Let's try that and see. It's not even on this list. So let's see. So it should give us false. 7761 should give us false. And we can see it gives us false. So this is working. One more thing that I wanted to point out. If you put in 1, right? We know 1 is not a prime number. It's not on this list. You may think 1 is a prime number, but it's not. It's not on this list here. And when you check anywhere, it's not going to. It's basically not going to give you, the right number. It's going to tell you that 1 is not a prime number. So and over here, it's not on this list. So, but if I put 1 here, it's going to probably say true. Because the even divisions is not going to be greater than or equal to 2, so it's going to return false. It's not going to return false. It's going to return true, but we can fix that. So run that and it says true. 1 is not a prime number, so a way to fix this is this. So apart from 1 and probably -1, apart from 1 and -1, any other number that doesn't have exactly 2 even divisions is not a prime number. Okay, any number that doesn't have exactly 2 even divisions, apart from 1 and -1, is not a prime number. So let's deal with 1 and -1 here. So 1, the reason why 1 is saying true is because 1 divided, it's going to start from 1 all the way to 1. Okay, this loop is going to start from 1 all the way to 1. 1 divided by 1 gives us a remainder of 0. So even divisions is going to be equal to 1. And it's going to check here is even divisions, which is 1. Is 1 greater than 2? It's not greater than 2. So it's not going to return false. But guess what? It's done also with the loop. It's done with the loop because it looped 1 time. So it's going to come here and return true, although 1 is not a prime number. So let's go ahead and over here say if, over here in this if state Boolean expression, if divisions, okay, I was exporting something. It doesn't want to go. Oh boy. All right. If even divisions is greater than 2, okay, now I'm going to extend this Boolean expression and say if even divisions is greater than 2, I'm going to say or. I'm going to use the two pipes to represent the or and surround this with parentheses just so I know I'm dealing with just one expression here. So if even division is greater than 2 or the user number is equal to 1, Okay, all these numbers equal to 1, return false. Probably -1 as well. You can do that. Or the user number is equal to -1, then return false. So if any of these conditions is true, return false. Or means at least only one of this condition has to be true for this whole Boolean expression to be true. So if any of these conditions is true, return false. Even if 2 of them are true, it's return false. If all 3, return false. If all 3 are true, return false. All it needs is for 1 to be true, and it's going to return false. So if at least 1 is true, return false. So if that number, if the even division is greater than 2, return false. If the user number is equal to 1, return false. If the user number is equal to -1, return false. Now we've fixed that problem. So now we know 1 is not a prime number. So let's compile this and then run it. And I'm going to now enter 1, and oops, yep, 1 was in the over here. So now it says false as opposed to true. As opposed to it's saying true initially. So 1 is false, but it still works, like before. So if we try 2 on this list, we know 2 is a prime number. So let's compile this and then run it. Now 2 is true. Try 1 again, compile it and run. 1 is false because try -1. I mean, it wouldn't even -1. I mean, you're dealing with positive numbers here, but I just put it in there just to show you. Oops, -1 is true. Let's see. Oh, okay. Okay, so well, first of all, -1 is not even part of a prime number. So we're dealing with positive numbers here. But if just to let the program test it, it's basically dividing 1, okay, by -1, which is giving me -1, right? It's not giving me let's see. Hold on a second. So it's basically dividing 1, okay, by -1, which is giving me -1. We want an even division. So we know that this is not even. Okay, we know this is not even as an even division because it's not. Well, actually, it's giving me a remainder of 0. Sorry, it's an even division. So we know. Well, we know that it's giving us -1. 1 divided by -1 is -1, and it's giving us an even division of 0. So it's going to keep track of that. But guess what? We're only going to have 1 even division. So and the loop is going to run once. So why is it returning true? It shouldn't return true. Shouldn't. The 1 is false. -1 should also give us false because -1 divided by 1 is going to give us -1 remainder 0, but it's only going to be 1 even division. And if it's over here, if it's not greater than 2, then it's going to go ahead and return. Let's see. If it's not greater than 2, then it's going to go ahead and return true. But over here, we've said if the user number is equal to -1, then print or return false. It shouldn't do that. Let me go ahead and surround this parentheses and just try. I need to figure it out, but let's see here. This is surrounding that, and this is surrounding the whole thing. Okay. Well, I mean, it doesn't really make a difference, but it shouldn't. It shouldn't do that. I'm missing why it's returning true. So return false. if the user number is equal to 1, all the user number is, let me try this. I mean, I did that already, so it's pretty much like what I did before. So returning true. Oh, so I think I know what it is. It's starting from 1 all the way to -1. I missed this. I missed this completely. Well, initially, first of all, when we are talking about prime numbers here, we are not even dealing with negative numbers here. I just wanted to put it in there because, well, if I said if 1 is not a prime number, then I guess -1 is also not a prime number. But over here we are not dealing with negative numbers even. So we don't have to even have to actually check to see if it's -1. I mean, just if you wanted the program to check that, just for you playing around with the program to make it really work with all numbers, then you can just do that. And also, the reason why I did this was also to show you that you can do that. You can rule out certain numbers. But the reason why it's not working is because it's starting from 1 all the way to -1. It's increasing 1, so it's not subtracting. So we have to subtract. So basically, it's starting from 1 all the way to the number itself. So basically, so that's what's happening. It's starting from 1 all the way to -1. So that's why it's returning true over here. That's the problem. But we don't have to check for this. But if we wanted to check for it, just make sure that it's just know that it was starting from 1. You see, if before even putting -1, we put in a positive number and it starts from 1 all the way to, let's say, 2. But if we increase, let's say, 1 to -1, think about it. We are not decreasing current division by. We are decreasing current division by, let's say, by 1. We are increasing it by 1 instead. So think about it. The very first time, we are checking to see over here. We are initializing current division to 1, and we are checking to see if 1 is less than or equal to -1. Okay, 1 is not less than or equal to -1. 1 is greater than or equal to -1. So what happens is this loop doesn't even run in the first place, and it's returning true. It's returning true. But like I said, we don't have to check for -1. But just in case you wanted to rule out certain numbers and you wanted your program to be able to check for any values, including negative values, then you can do that. Then you can do that. But then what you have to know, if you put let's say a -1, if you did -1 and you wanted to know why it didn't work, now think about it. Current division starts from 1. Okay, and it's checking to see if current division is less than or equal to user number. It's asking if current division, which is 1, is less than or equal to -1. Is 1 less than or equal to -1? 1 is not less than or equal to -1. 1 is greater than or equal greater than or equal to -1. It's actually greater than -1. So in that case, this loop, it doesn't even run. So it just jumps. This loop doesn't run. It just jumps straight to the return statement here and returns true. And that's why -1 is returning true. And I completely missed it. I was going through the program and I thought to myself, let me just look up here. I was just thinking it should work just because it's a Boolean expression and it should result to true. But yeah. But if you really wanted to fix this, you can. You can delete it here. You can delete this here. And check it below. You can delete this here and check it before this just true statement here. So that was a problem. It was checking to see if 1 was less than or equal to -1. 1 is not less than or equal to -1. 1 is greater than -1. So this loop doesn't even run. It just jumps straight to the return statement and returns true. But -1, we want it to return true. Actually, we want any number that's negative to return true. So let's just, if we wanted to do that, we could have done that. We can do that here before it comes. If it's a negative number, before it comes here, before it comes down here to return true, we can check for an if statement. We can basically introduce an if statement here and say that if user number, or even before this, we can just, if we wanted to do that, we can check over here before the loop even starts. We can check and see if user number is less than 0. If it's a negative number, or let's say if it's actually less than 1, because we're starting from 1 over here. If it's less than 1, then let's return false. Let's return false, because 0, we don't want 0 to say true or anything. So if user number is less than 1, it's less than 1, because we are starting from 1 over here. If it's less than 1, then let's go ahead and return false. Now, when this return statement executes, it's going to jump out of the method. None of these statements are going to run. This return statement just exits out of the method. The same thing with this return statement here. If it executes, it jumps out of the method, and none of these statements below it run here. The same thing with this one. If it executes, it jumps out of the method. So we can check it here and say if the user number is less than 1, meaning if it's 0 or negative numbers, return false. Those are not prime numbers. If it's 1 over here, and if the even division is greater than 2, return false. That's not a prime number. Anything apart from that is a prime number. Anything that is not negative, that is not 0, that doesn't have even divisions of exactly 2, or basically that has even divisions greater than 2, and if that number is 1, is not a prime number, so return false. Otherwise, then return true. So now let's try this and see. I think we're missing. We need to close this parentheses here. So I'm going to close it here. So another one here. It's not isPrime. What is it saying? isPrime cannot be applied to. Okay, no, it needs a number here. Okay, so I'm going to type in -1 here now. Compile this and run it, and now it says false. See, -1 is saying false. 1 itself is also saying false. 0 is also saying false. -50 saying false. But when we continue with our regular numbers here, which is 2, 3, 5, let's try 2, and it's true. If we try 4 we know it's not a prime number, right? So to say false. 5, actually 3 is true, because we know 3 is a prime number. Let's try, we already tried 4. Let's try 5. 5 we know it's a prime number, so we should expect true, and it's working over here. True. Let's try one random number here. 63709. 63709, right? 63709. That's what I was looking at over here. 63. I missed it. No, actually it was 4 numbers. I missed it, I guess. Let's try another number. 7027. 7027. Right? 7027. It should be true. And you can see true over here. Now 7027 is prime. We know 7028 is not on this list. Even 7029 is not on this list. So let's try 7029 and it should give us false. So 7029. And it gives us false. So everything is working. If the number is negative, it's returning false. If the number has more than 2 even divisions, or that number is 1, it's returning false. Yeah, so if that number is also less than 1, 0, or negative numbers, it's not a prime number. Anything else is a prime number, so return true. So basically this method is checking well to make sure that number is not prime and returning true or false. So yes, we are done. I completely missed why over here. I mean the boolean why the negative one wasn't working here. The boolean expression was working fine, but I forgot about the header here, and I forgot that I was starting from 1 all the way to the number itself. So it was checking over here. I forgot about this. Actually, it's not like I forgot. It skipped me to check. It skipped me to check. So it was checking over here to see. It was starting from 1 and checking to see if 1 is less than or equal to -1. 1 is not less than or equal to -1. So this loop wasn't running, so it went straight to return true. Anyway, we have fixed it, and I'm glad. And I'm glad you also hopefully understand it. All right, so thank you very much for watching. If you have any questions, please comment down below, and I'll do everything to respond to them. Take care of yourselves, and I'll see you next time with the next program. All right, bye-bye.